Hi, this is my first attempt at doing a little video here for um, grade 9 pre-IB, chapter 3.1 in relations. As you can see in front of you, I hope you can see anyways, here is the handout, which will be on the group pre-IB notebook in Teams or on OneNote. I think going into Teams is probably the best way to go about doing that. So now I'm going to go through this with you, and we'll see how it all turns out, and we'll see if this recording will work out for you. So I guess the idea would be for you to go into OneNote, I guess through Teams, probably because that's where I created this OneNote in the first place, and download the worksheet, print it out, and then you can go along with me here, or if you want to travel at your own speed and go through this a little quicker, that's perfectly fine. But we'll just kind of go through this, and then I'll make sure I point out important steps, important things for you to do while you're going through this, and important features to look for and pay attention to. Okay, so first of all, we're starting chapter 3, which is all about relations. A relation is a description of how two variables are related to one another. So how does X relate to Y, or how does Y relate to X? There's a few things that we're going to have to deal with as we go through this, but I'll show you some of the important terminology as we go. So we'll start off with the table of values. So here's an example. The cost of a banquet at one's banquet hall is $450 for the room rental. Okay, and let's see, I will highlight this. So $450 for the room rental. That wasn't very, whoops, that's not very straight at all. Plus plus $15 for each person that attends the banquet. So we want to create a table of values and scatter plot to represent the relation between number of people and the cost. So here we've got number of people in the left-hand column of this table, and the cost on the right-hand table, on the right-hand column. So we're going to need to populate this table so then we can plot the appropriate points on the grid to the right. So number of people is 0. So before anybody shows up, what is the cost of renting the banquet hall? So this is like the costs, this is the costs for the people who are putting on this banquet. So what are the costs? Well, it says up here, $450 for the room rental. And so now why might a place charge $450 for just to rent the room in general? So think about that for a second. You might even want to pause the video for a second and just think about, why is there a rental fee or a reservation fee that you might want to call it, and in this case $450. So basically, so that rental fee has to get paid up front, and that's before anybody shows up. So number of people is 0. The cost is going to be $450. As I try to write here, I might actually change that to a smaller size, just so I can write a little bit better. Okay. So why might they have a rental fee for this? Well, what if the person who rents one's banquet hall decides at the last minute, oh gee, I can't do it that weekend, I got to do it some other weekend, and it's like the Friday before, renting it on the Saturday or whatever, then Juan's banquet hall won't have a chance to rent it the next day to somebody else. So they'll charge the $450 to make sure that if anybody does back out, that they'll they at least have the money for it to start out with. And the other possibility could be for damages or whatnot. Then we know that if we look over here in the blue highlighting, that there's $15 for each person that goes. So once 10 people are invited, we've got the initial 450. That's the rental fee, plus we've got 10 people that are all being charged $15 each. So 10 times 15, well, we have to use GEDMAS again, so we have to make sure we follow the order of operations. So 10 times 15 would be 150. 150 plus 450, that would be 600. Okay, so if 0 people show up, the person running the banquet is going to pay one's banquet hall, or they're going to owe them $450. If 10 people show up, they'll be owing them $600. So that $15 per person, that's basically, I mean, if it's a banquet, usually banquets are serving some sort of meal. So that would be $15 for the meal for each person. Then we move on to 20 people. We're starting off obviously with the $450 rental fee. Then we've got 20 people. So this is not in addition to the 600. This is a brand new calculation. So we have to take the $450 rental fee. That's the starting point anyways. And now we're calculating, well, what if 20 people show up? So we're not adding that to the 10 people who showed up before. That was a separate calculation. Now we're jumping to see, well, how many people, or what's the total cost if 20 people show up? So 20 times 15, of course, order of operations again, 20 times 15 gives us 300. 300 plus 450 will give us 750. Then the next milestone of people that would be invited or might attend the banquet are 30. And so again, $15 a plate, multiplied by 30. Well, 3 times 15, I know 3 times 10 is 30. 3 times 5 is 15. So 3 times 15 would be 45. And so 30 times 15 would be 450. 450 plus 450 gives me 900. And this pattern is going to continue because each time here, each time we're increasing by 10 participants or 10 attendees. So the common difference in the number of people attending is 10 each time. So the pattern of increase for the total cost is going to increase as well. And actually, I'm going to put up here total cost, because this is the total cost, the cost of the number of guests, the meals that they eat, in addition to the rental, the room rental of $450. So that's the total cost. And I see now 450 up to 600. Well, that's an increase of 150. And then I see from 600 to 750, it's also an increase of 150. And then from 750 to 900 is another increase of 150. Because each time I increase by 10 people, I'm increasing by $15 per person, which is, we're increasing by $150 to the total. So there's 150 increasing for each of those total costs altogether. So if I just continue this pattern now, 900 plus 150 is going to be 1,050. I would have calculated that by doing the same thing as I did in the previous 3 lines. And then 1,050 plus 150 would be 1,200. And then 1,200 plus 150 is 1,350. Okay, so here we have all our values, and each of these values can be stated as an ordered pair. What's the total cost when 0 people attend? $450. What's the total cost when 10 people attend? $600. The total cost when 20 people attend is $750. Total cost when 30 people attend is $900. So that continues. So it looks as though the total cost depends on the number of guests. So we're actually going to call this the dependent, and because this keeps changing, we're going to call this the dependent variable. Okay, that's the dependent variable. Because it keeps varying, it changes, so it varies. So the dependent variable is the total cost, and it depends on the number of people that attend. So we're going to call this then the independent variable, because independent of the total cost, these are the number of people that are going to attend. And then the total cost then will depend on the number of people that attend. So there's a bit of protocol here when we now deal with the grid and the tables of value, the graphing of this, the scatter plot, I should say. So first of all, we need a title, and every graph needs a title because we have to know what we're looking at when we look at a graph. So I'm going to say total cost of renting. I'll probably run out of the room here. Renting the banquet hall. Okay, sorry, please excuse my handwriting. So total cost of renting a banquet hall. So now when you look at the title, you think, okay, so we're looking at cost, we're looking at total cost. And so then now, excuse me, the dependent variable, that will go along the vertical axis. Okay, the dependent is always in the vertical axis. So now I know I kind of like am squishing out the spacing here. But along here, let's see if I can use a different color. Yes, mauve. So I'm going to say here, so this is going to be what's called the label. What I'm going to write here is the label of the vertical axis. I'll write it down here so I have a bit more room. So I'm going to say total cost. So you want to be very specific. So total cost, this is the label, and I'm saying the units are dollars. Okay. Oh, and just so we're clear here, they put the unit of cost in the heading of that column. If we were to put the dollar sign, we don't need it because we're saying, okay, all of these values along here are dollars. But if we were to put this dollar sign in the table itself, the dollar sign always goes to the left of the value. Now, it's not the same in every culture. But in North America, the dollar sign, even though we say dollars last, $450, the dollar sign does go first. I know a lot of people with their stores and trying to be cool on social media or whatever, they're changing things and they put the dollar sign afterwards. But to be precise and to be correct, dollar signs go to the left of the value. Now, like I said, we don't need to have the dollar signs in there because the unit is up here in the heading of that column of the table of values, but I'm just demonstrating where it would go, where it needs to. Okay, so back to the label of the vertical axis. So there's the total cost. If these values weren't here, squishing in out of that space there, I would write this total cost label up but midway through, or maybe even write it vertically. I'd kind of turn my head and write it sideways there. And then along the bottom, we need a label here, and this would be the number of people. We can say number of people, number of attendees, but I'll just put here people for now. Okay, so there's that part. Now, the important thing is the scale. And the scale has to be set along here. Usually the independent scale is easiest, so let's do that first. So we're going to start at 0. And that 0 is going to, in this particular case, is going to be for both axes. So then, so I know I'm going up by tens here in the left column of the table of values. And along the bottom here, I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got about 9 spaces here. So I'm just going to go up by tens. So I'll put the scale. Now notice that the scale, first of all, the scale is going up by the same value, and what's really important about the scale is it has to be evenly spaced all the way along each axis. Okay, so notice I'm going up by 1 space each time. So 1 space, then 2, then 3. And so I'm increasing by each space, and I'm increasing by the same value. Okay, that's very important. It has to be all uniform all the way along. Okay, and then now going up the vertical axis. Now in this case it would work out just fine, but I don't want to get into this habit. But when you set out, if we're doing a table of values or a scatter plot from experimental data, where the values don't go up by a perfect amount each time, like we did here, a standard amount, then, or sorry, I guess even better, a uniform amount, like is seen here with 150 increases each line. It's really important to have the scale, again, go up in a uniform manner with uniform spacing. So I see that the smallest value is 450. The largest value is 1,350. So the smallest value is 450, and the largest value is 1,350. So with this largest value, I know I want the grid, the scale, to go up just a little bit above that. So this point can be graphed on the grid without having to go up above the grid, the top of the grid. So I'm going to count the number of spaces I have here. So for every line, so I'm going to jump. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Perfect. Okay, so I got 14 spaces. I need to go up to at least 1,350, which means I'm going to label up to 1,400. And if I've got 14 spaces and I want to get up to 1,400, what would be the best value that I could increase by? Well, I think, technically, and I'm sure you would agree, I hope you do anyways, as I go up in uniform manner, I'm going to actually be going up by 100s. So I got 100, then 200. And notice that I'm marking the lines and not the spaces themselves. Okay, so the 300 goes on that line, 400 goes on this line. I'm going to come down here, 1,400, 1,300. Okay, so I'm not as precise as I should be, as this is day 1 on this tablet and this format here, video producing. But I'm trying to make sure I squeeze in all the values and line them up with each of the lines. And that 500 looks horrible, but anyways, let's just pretend we know it's 500. Okay, so there's the scale, the vertical scale, the horizontal scale. We got the title. We've got both of the labels for the axes, so we're all set to go. Now it's time to start plotting the points. And I'll use green because I got a lot of red and purple in there. So for 0 people, the total cost is $450. So we need to see where those two values will intersect on the grid. So I see along the bottom, we've got 0 is actually this axis, this thick dark line here, which is the vertical axis. So that's 0. And I see we're counting up by hundreds, and 450 is actually right in the middle between 400 and 500. So I'll see if I can be accurate enough and put the plotted point there. It's kind of messy, but a plotted point right on the grid. So that corresponds with 0 and 450. Then I go to 10, and 600. So go along the bottom to 10 up to 600, and where those two lines intersect, I'm going to plot a little point, and then I go to 20 and 750. So 20 along the bottom, 750 up along the top, or sorry, along the vertical axis. So that's 750 right there. 30 and 900, so 30 along the bottom, along the independent axis, 30 and go up to 900, so plot another point here. 40 and 1050, so 40 and 1050 is going to go here. 50 and 1200 is here. And then I've got 60 and 1350, which would go right about there. Okay, and if you kind of eyeball that, you can kind of see that it's actually rising up in pretty much a line as you go along from point to point there. Okay, all right, so we're not going to join those points right now. That'll come a little bit later. But we have a couple questions maybe to discuss here. So what variables are being compared in this example, and which variable depends on the other? So we have already discussed that. And so the two variables are total cost. I added in that word total before. The total cost, and I'll answer both of these questions at the same time. Total cost depends on number of people. Okay, so we've got the number, the two variables. So total cost is one, and number of people is the other. Okay. Next question, what are some of the patterns in the table? Well, what do we notice in the table of values? What patterns do we see? Well, we see for the number of people. Now, number of people is what we've chosen. So we chose to increase by 10. Okay, so number, I'll just use this number sign. Number of people increases by 10 each line. Okay, there's one pattern. And notice that that's actually a constant. We say that that's a constant increase because the increase each line from one line to the next is constant. It's always 10 in this particular case anyways. And then the pattern of the dependent variable, we see that it's increasing by 150 each time. I'll just do a quick highlight of those. 150 is increasing each time here. And had I continued writing it, I would have written 150 down for the last few lines as well. And so the total cost increases by 150. Again, I apologize for my writing. First day on the tablet here. So now if you notice, so there's a few things to notice here. First of all, up here in the description, it says that each person is charged $15 for the meal. Then we notice that the number of people increases by $10, or sorry, by 10 people, and the total cost increases by $150. Well, how did those two values relate to each other when we know that each person is charged $15? What if we were to take the total cost? I'm going to run out of the room here, so I'll say tot cost. Total cost of $150 and we divide that by a number of people, people, I'll just short form that, number of people, and if you were to divide 150 by 10, we see that we do get 15. Okay, so it all sort of comes together, and it all makes, I'm not sure if it makes sense to everybody, but it all comes together and is all consistent with the values that we're given. Okay, so hopefully, if you have any questions about this, please don't hesitate to send me a note. Now we come down to the terminology, and we have already discussed this a little bit. The independent variable in a relation, the variable whose values you choose, so we chose the number of people that were going to be attending the banquet, placed in the left column of a vertical table, so up here, so it's in the left column up here, and on the horizontal axis in the graph. I'm also going to add one more small thing here. If we had a horizontal table, it's in the top row. So add this along here too. It's in the top row of a horizontal table. Okay, so sometimes people write tables that are not vertical, just maybe save space somewhere along the line of whatever they're working on. And if they rotate this table that we wrote here, this vertical table, and they turn it horizontal, the number of people would be on top, the top row, and the total cost would be the bottom row. Okay, and the fact that the top row is independent and the bottom row is dependent, those dependency and independency would not change. And I think I moved that a little bit. There, okay. Now we come down here to the dependent variable. And the dependent variable in a relation, the variable whose value you calculate. So we calculated all of those total costs. Okay, so all these total costs in the right-hand column of the table, we calculated all those. And so those are the things that we calculated. Those are the dependent variables because they depend on the variable on the left. It's placed in the right-hand column of vertical table and on the vertical axis of a graph. And of course, I'll just add in here the bottom row of a horizontal table. Sometimes you will see that. Okay. So I'm going to move down here a little bit. Creating table of values and equations. Okay, so here's a different example. Again, like I said earlier, if you have any questions about any of this stuff that we just looked at, please don't hesitate to send me a note, and I will try to help explain that with you. Second example here, the monthly fees at a particular bank are as follows: $12 service fee, the service charge, plus, I have to pay attention to the wording, 50 cents for each transaction. So what are the two variables in this case? Well, what are the two things that change? What are the two things that change? So we see there's like a service charge, and we see that plus there's a 50 cents. So those are values, and these values don't change. 12 is always 12. 50 is always 50, and I'm not sure why that jumped. Let's see if I can delete that. There we go. So 50 here is always going to be 50. The things that do change, though, are the fees. So the fees change from one month to the next, and the transactions change. Now, which one of those depends on the other? So the transactions would be actually the number of transactions, not just the transactions, but the number of them. That's what would actually be changing. So which of these is the dependent variable? Well, which depends on the other? Do the fees depend on the number of transactions? Or would somebody make a number of transactions depending on the fees that they're going to get charged? And to ease your minds, the fees depend on the number of transactions. So the number of transactions comes first and the fees follow that. Okay, so that's the other small thing about the independent variables. The independent variables are the things that happen first. So therefore, the number of transactions, I'm never going to squeeze all this in on this line, so I'll put just a number of transactions. I'll put this down below here. Okay. So the number of transactions is the independent variable. So that comes first. The number of transactions will happen first, and then the fees follow that. So we use letters to represent the variables. So this is called defining your variables or introducing your variables. So defining or introducing the variables. You always have to do this. There, the variables. So we have to define the variables or introduce the variables to make sure that the reader knows what letters you're using and what they represent. Now this is a very important thing. First of all, I usually use the letter that is at the beginning of the word of the variable. We don't have to do that. We can use X and Y, T and S or whatever. I'm going to use F and N for now. So I'll say F, let F represent the, I'm going to say the total fees. Okay, because again, we're talking about the $12 service charge plus the 50 cents for each transaction. So I'm going to say the total fees. And now, going back up here again, sorry, I just have to point this out. The monthly fees, they're monthly fees. Well, what we're actually going to be looking at is we're going to be looking at the fees just in 1 month. Okay, so we're not going to be looking at the fees over a year, because then that would be, we'd have different months and different fees. So we're adding in too many variables. So we're going to start with just 1 month. So we're looking, all of these fees are going to take place just in 1 month. And so those are the total fees for the month. And then, so getting back down to part C here, representing the variables, I'm going to say actually N. I'm not going to use T. I'm going to use N for the number of transactions. And it's really important that we talk about the number of transactions. So when you're introducing your variables, you can't just say it's transactions, because we need to know it's the number of transactions. Okay, that's a very key thing that you're going to have to abide by. It's number of transactions, not just transactions, because we're dealing with numbers here, okay? So we can now develop a formula to calculate the total fees. Okay, so the fees are determined by, well, we got $12 service charge. So every month we have to pay $12 plus 50 cents for each transaction. Well, the $12 is in dollars. That's $1. And notice I'm not putting in the dollar sign here. We don't need any units in formulas at all. We put the units in at the very end. And so we got $12, and this is in terms of dollars. Up at the top here in the description, it says 50 cents. But that's in cents. But what we need to do, we need to keep these both in the same units. So to keep the number smaller, instead of saying this is 1,200 plus 50 cents per transaction, I'm just going to say this is $12. And so how would I write 50 cents in in the portion of $1. So I would be writing here plus 0.5. And I'll put the 0 here just to remind you that we're talking about money. And for each transaction, so it's 50 cents for each transaction, and the number of transactions is represented by n. So if there's one transaction, it would be 50 cents. If there's 2 transactions, it would be $1. 4 transactions would be $2. So we could continually add up 50 cents each time, but it's quicker if we were just to multiply the 50 cents by the number of transactions, so then we can get a total fee at the end here. So here is the formula. F being the total fees equals 12 plus 0.50n. One small thing here, when you have when you use a calculator to calculate these things, the calculator doesn't know you're using money, so it'll probably just cut off the 0 at the end, so it'll probably say 12.5. When you write it down, please put in that 0 at the end to make sure that we're talking about money. Okay, so here's the n, the number of transactions, and here's the total fees. So remember, the total fees are and that's in dollars. The total fees depend on the number of transactions. Number of transactions are independent because they happen first. Total fees depend on those. So that's here in the second column, in the right-hand column. So when there's 0 transactions, what's the total fees you have to pay the bank every month? Well, even if you don't use your bank at all, you're going to have to pay them $12. If you use the bank 5 times, you do 5 transactions. Well, 5 times 0.5, so I mean, we're going to start off with our $12 fee plus 50 cents per transaction multiplied by 5 transactions. So 50 cents times 5, well, if you count out 50 cents 5 times, that's $2.50. Add that to 12, and we get $14.50. Then if we skip over the 5 and we just calculate the 10 transactions, $12 monthly fee plus 50 cents times 10 transactions. So 10 transactions by 50 cents each is $5. $5 plus 12 is $17. Then we go up by 15. We go up by $5, 5 transactions to calculate what the total cost would be if we were to do 15 transactions. And so notice, of course, we keep increasing by $2.50 each time. So from 12 to $14.50, that's an increase of $2.50. If we go from $14.50 to 17, that's also an increase of $2.50. And again, 2 more times, $2.50. So that's going to be $19.50. And then we'll do that again. So $19.50 plus $2.50 is going to be $22. And the reason why I know that it's going to be increasing by the same amount each time, first of all, the first 3 went up by the same amount, and also the number of transactions, I've already chosen that they're going to go up by 5 transactions each time. So that's going to be constant as well. So both the number of transactions is increasing by a constant amount, and the total fees are also increasing by a constant amount. Okay. Here we see a grid. Again, just like the other grid we had in the previous example, we're just using, like, this grid actually comes from an actual full Cartesian plane. But what we're using here is just we're just using this, the first quadrant right here. That's the only part we're using, is we can see that would match up with this grid here. Why do we only have to use this first quadrant? Well, if you remember from past years talking about the values on number lines, etc., the vertical value, vertical number line of y and the horizontal number line of x, to the left of the intersection point along the x, those are all the negative values, and below the intersection in the y-axis are all the negative values. So because the total fees are always going to be positive, and the number of transactions will always be positive, that means we only have to deal with the positive values, the first quadrant. So we can just say that all values used, or all values are positive. Okay. And then using the graph, estimate the total fee for 7 transactions. So here's the thing. I'm thinking of running out of time here with this video, but I'm going to actually ask you to graph this, to plot the scatter plot yourself. Include a title, include the labels for each of the axes, put in your scale appropriately. I'll do the hard part for you and just make sure that we're on the right track here for the scale for the vertical axis. So I'll just go up by 5s for each of those lines. Again, it has to be uniform spacing and uniform increase in values on both axes. I don't know if you want to go up by $5 here, going up by $10, the graph would be really squished. So 5, 10, 15, 20, 25, that might just work here. So if we go up by the $5 amount, then we see it as, oops, Amber Alert. I'll check that in a little bit. And so notice that there's a uniform increase in values and a uniform spacing along the vertical and horizontal axes, and then we'll plot the points. And so once you plot the points, what you can do is you draw one straight line through all the points. Don't go point to point. So if you're off, don't worry about it. Just use a ruler and draw one straight line that will go through all the points the best you can. And then to estimate using the graph, so when you use the graph to estimate, for 7 transactions, you're going to estimate where along the number of transactions axis 7 is. You kind of estimate where 7 is. And then you're going to go up to the line, wherever the line is. And then once you hit the line, then you're going to come across. And then you're going to see what that value is. Now, I think well, obviously I've gone too far. But you're going to go up to the line and hang a left and come across and see what that value would be for 7 transactions. Okay, and then we're just going to put that on the line here. Okay, so I'll let you continue that part, please. And then the last little bit here, interpolating. So there's always values that are low values and high values of your table of values. So the lowest value in the horizontal axis is 0. The highest value is 20. So these create what are called poles. So we've got a pole here at 0, and we've got a pole here at 20. Okay? And those sort of dictate where all your points are going to be plotted. So between 0 and 20. So those are the 2 poles. And if you're estimating a value between these 2 poles, like inside, that's called interpolating. It's within the range of the data points, okay? between the two values, between the highest and lowest known x values. So these are the x values are the independent values. And then we talk about discrete data. Okay, yeah. Sorry about that. I will check that out, I promise. The discrete data is data that cannot be divided into smaller parts without losing its meaning. Basically, these are counting numbers. Okay, counting numbers are discrete data. So if we're going up by ones, or if it's something that you can count, it's discrete data. So the number of transactions, the number of pencils on your desk, the number of desks in the room, the number of cars you can wash, the number of windows you break, the number of houses that are on the side of the road. Anything that has number of, that's discrete. Other things that are continuous, and so like I said, if you're counting number of pencils, a pencil is a pencil. So we're not going to break a pencil in half and say, okay, well, there's 2 pencils because it actually came from 1. Or if you're talking about number of cars you wash, if you wash half a car, you're not really washing that full car. So you can't count a half a car as a car. So number of lengths you swim in the pool, if you swim half a length, that's not a full length, so you can't count it. So we're talking about full, complete objects for discrete. And then when we get down to continuous data, we can divide it into smaller amounts, and it still has meaning. So if we're talking about height, somebody can be 5 feet tall, somebody can be 6 feet tall, but they can also be 5 feet 5 inches, or 5 feet 5.5 inches, or 5 feet 5 3/4 inches. So we can break it down into smaller pieces, and it still makes sense. When we grow, we don't like grow from 1 foot to 2 feet to 3 feet like instantly like that. We actually grow gradually over time. So just the same thing as money grows in the bank bit by bit, we can break things down into cents, dollars and cents. Just like time passes, days, minutes, or hours, minutes, seconds, we can break that down into smaller pieces as well. And all of that still makes sense. So things like time, money, distance, that kind of stuff, those are all examples of continuous data. Okay. All right. So so just to note that the 2 graphs that we've drawn today produce straight lines, and actually we don't even need the word straight. I'm going to cross this out. Because in math, a line is always straight. So you don't have to use a straight line. We can just use the word line, and people who understand math would know that line is straight. If it's not straight, then we call it either, well, we call it a curve. A line is an example of a linear relation. If it's a curve, it would be a non-linear relation. Okay, so those are the differences there. Okay, so both these graphs are lines, and they're examples of linear relations. All right, here's the work I'd like you to work on. I may revise this list. I'll take a look at it and see, and then I'll let you know if I want you to do all of this tonight or just a little bit. Anyways, that is the lesson for 3.1 on linear relations, and we will continue with this in coming days. So good luck with that. If you have any questions, please don't hesitate to reach out and send me a note, and I will answer you the best I can. All right, thanks a lot. Talk to you soon.